Welcome back. In the previous video, we added a camera, boom, and a follow camera to the shooter character. And now if we press play, you'll see that we can see the capsule because the camera is 300 units away from the capsule component. But if we click into the viewport and try to move around, we can't move because we haven't programmed any movement functionality. That's what we're going to do in this video. So first, we're going to need a couple of functions for moving the character. We're going to map these functions to the WASD keys as well as thumbsticks for a console controller. Every frame, we need to check to see if these keys are being pressed or if the thumbsticks are being pressed in a certain direction. We can set up those inputs by going to Edit, Project Settings, and clicking on Input. There are two types of mappings for input: action mappings and axis mappings. Action mappings are for one-off key presses, so you press a key and a function gets called a single time. Axis mappings happen every frame, so they're continuously receiving data about those key presses each frame of the game. We're going to create a couple of these, so press the plus button and then the drop down should appear. We're going to call the first one Move Forward. Now Move Forward is going to be mapped to the W and the S keys. You'll see right here it says select the key value. If you click on that and then press the key on the keyboard, such as W, then it'll select that key for you. Let's go ahead and press the plus icon so we can map another key to the Move Forward mapping. Click the icon and this time type the S key. Now to the right we have the scale value, and I'm going to scale the S to -1. Now what happens is every single frame we're now listening for whether or not the W or S keys are being pressed. That information will be fed to the functions that we bind to this axis mapping, and we're going to get to that shortly. We also want to add to the Move Forward mapping, and this time we're going to search for gamepad left thumbstick x-axis. This is the left thumbstick on a console controller, and we're mapping only the x-axis of that, which is the left and right movement of that thumbstick. Let's create another axis mapping, and this one we're going to call Move Right. For Move Right, we're going to map the D key. Let's add another one, and we're going to map the A key. And the A key is going to be scaled by -1. Finally, we're going to add another one, and this is going to be the gamepad left thumbstick y-axis. This is the up and down motion of the left thumbstick. So every frame, the engine checks to see whether these keys are being pressed or what the value is for the thumbsticks, and we're going to bind a function to these axis mappings that will receive that information. Now we only need a single function for moving forwards and backwards, because when we're moving backwards, we're going to call the same logic except the value for the input is scaled by -1. So it'll move in the opposite direction. The same goes for Move Right. When we're trying to move left with the A key, we're going to call the same function, only our input data will be scaled by -1. We can close project settings. There's no need to save anything, it's saved automatically. So let's close that. Okay, so now we can create some functions to bind to those axis mappings. Let's go back to Visual Studio. And in Shooter Character, we're going to add a couple of functions to the protected section. This way they can only be called from within this class or a class derived from this class. Our first function will be a void function called Move Forward. And it's going to take a float called value. This is the value that we'll be receiving from our input based on our key presses and the thumbstick x-axis position. Let's give this a comment. We're going to say called for forwards/backwards input. We're also going to create a void function called Move Right. This one will also take a float called value. We'll give this one a comment, and this will say called for side-to-side input. Now here in Visual Studio, we can go ahead and allow Visual Studio to create a definition for us. This is a nice shortcut, so I'll click that, and you'll see that it created the definition for me in shootercharacter.cpp. I'll close that, and I'll do the same for move right. Now I can close that, and back here in shootercharacter.cpp, I can scroll down and see my move forward and move right functions. So now we need to define these. First we'll define move forward. We're going to make use of our controller. The controller is what possesses the pawn, and the controller is facing a particular direction, and whichever direction the controller is facing, that's the direction the camera will be facing. We're first going to check to see if our inherited variable called controller is valid. So we're going to do an if check. We're going to say controller. And we're going to make sure that controller is not equal to null pointer. Now we're also going to check, now I'm going to place these in another set of parentheses because I'm also going to have another check in here. I'm going to say and with a double ampersand. And my second condition is that value is not equal to 0. If the controller is null, or if the value is 0, then we don't even need to perform anything in this function. But if this if check succeeds, then we can move the character forward. So first we need to find out which direction is forward. So I'm going to add a comment. Find out which way is forward. I'm going to create an F rotator. It's going to be const because I don't plan on changing this, and it's called rotation. I'm going to initialize it by calling controller get control rotation. So this is a function that gets the rotation of the controller. So whichever way the controller is facing, we're going to get that as an F rotator. If you don't understand what an F rotator is, I recommend you take my other course, Unreal Engine C++, the Ultimate Developer course, which goes into more detail about what an F rotator is. I'm next going to create another const F rotator. And this one I'm going to call yaw rotation. Yaw rotation is going to be the rotation that we got from the controller, except the pitch and the roll will be zeroed out. We only want the yaw component. So I'm going to say 0, rotation.yaw, 0. So now we have a rotator that corresponds to our controller's orientation, only we're zeroing out the pitch and the roll. We only want the yaw direction, which is basically the direction that you would get if you stood upright and turned around in a circle. Whichever direction you're facing, that's your yaw. Next, we want a vector corresponding to this direction. So I'm going to create a const local variable of type f vector called direction. And I'm going to initialize this with the following. I'm going to create an F rotation matrix. And I'm going to create this F rotation matrix passing in yaw rotation. This creates a mathematical construct called a matrix that is characteristic of the yaw rotation. And the rotation matrix has a function that allows us to get one of the axes of that matrix. We want the forward axis of that matrix corresponding to this rotation. So we can call get unit axis and this function requires an enum constant specifying which axis. The enum constant is called e-axis x. That's the forward axis. So this function will get the x-axis direction from the rotation matrix. And a rotation matrix can be constructed using a rotator, which we used yaw rotation. So In a nutshell, direction is pointing in the direction that corresponds to our controller's orientation. We're going to use this by calling add movement input. Add movement input takes a world direction, that's why we're passing in direction, and a scale value. We're going to scale it by value. Now, if we're pressing the W key, which is our forward direction, the value variable local to move forward will be 1. But if we're pressing the S key, which is backwards, value will be -1. So add movement input gets scaled by value, which takes care of both the forward and backward directions. Add movement input simply moves our character, and other information in the movement component determines how fast the character goes, such as max walk speed and things like that. All we need to worry about is calling add movement input and telling our movement component that we need to move. Now the move right function is going to be very similar. In fact, we can copy this if statement because we're going to perform the same check. The only difference is we're going to find out which way is right instead of forward. So we're still going to get the controller's rotation, and we're still going to get the yaw component of that and initialize a new rotator called yaw rotation. But this time, we're going to create the F rotation matrix from yaw rotation, and instead of getting axis X, we're going to get axis Y, which is the right vector of this rotation matrix. And then we're going to call add movement input with direction scaled by value, just like we did with move forward. Now we've got these two functions, but we never call them. The last thing to do is to bind these functions to the axis mappings that we created for our key presses and the gamepad thumbstick. We do this in setup player input component. Setup player input component has access to something called the player input component. This is what we use to bind functions to axes. Now we can perform a check to make sure that the input component is valid by using the check macro and passing in player input component. This performs an assert that will actually halt execution if the player input component is not valid. To bind our functions to the axis mappings, we're going to call the function bind axis on the player input component. So let's say player input component bind axis. Now bind axis is going to take the name of the axis mapping. Our first one we called move forward. Be careful here, this has to be spelled exactly the same as we spelled it in our axis mapping in the input settings. And it's also case sensitive. Next, it's asking us which object we're binding on, and that's going to be this. Now it's expecting a callable object, and we can pass in the address of our move forward function. So we're going to use the address of operator and pass the fully qualified function name, a shooter character, scope resolution operator, move forward. So bind axis requires the axis name, the class we're using this on, as well as the address of the function we're binding. We can do the same thing to bind move right to the move right axis mapping, only we have to make sure that the string says move right and the function being called is move right. And that's it. Let's go ahead and compile this. Okay, let's hop back in the editor and press play. And if we click in the viewport, we'll see that we can move forward, backward, left, and right, so our movement mechanics are working properly. Excellent job. Now I've also got a console controller plugged in via USB, and I'm going to go ahead and use the console controller to move around to test this out as well. Now it looks like when I press forward and backward, I'm going left and right, which means I should have used the y-axis for move forward and the x-axis for move right. That was a human error, so I'm going to go back to project settings and click on input, and change move forward to use the gamepad left thumbstick Y-axis. And I'm going to choose move right to use the gamepad left thumbstick X-axis. Now if I press play and test out with the controller, it's working as I intended. Moving up with the thumbstick moves me forward, down moves me back, right moves me right, and left moves me left. So that's working as expected. Okay, this concludes the video on move forward and move right functions. In the next video, we'll program the functionality for the character to be able to look around in all directions. Stay tuned.